All right, welcome everyone. We're gonna try to make this a little energetic, and you guys all look like you're falling asleep. So we're gonna try our best to make sure that doesn't continue to happen. I'm here with my co-founder, Callum Moore. He's the CTO of Polybase. I'm the CEO of Polybase. And we're gonna take you through on-chain privacy, the industry, where it's been, where it's going. We'll tell you about why privacy is important in the blockchain space. And then we have some exciting announcements at the end as well. Maybe I'll just, OK. So first, why is privacy on-chain important? So we see a lot of new use cases within the last 5 years of people using blockchain, not just for peer-to-peer transactions, but things like getting paid in crypto via payroll from actual companies in the space that are paying in crypto. We also see people taking out loans. We see real-world assets coming on-chain, like treasuries. And our thesis is that, look, if regular people are going to be transacting on-chain, having all of that be public is extremely problematic. We already hear from a lot of crypto payroll providers that people are getting in trouble because their pay is public, essentially. And so we are going to talk about how we can solve that, but solve that in a way that doesn't go in the tornado cash route and get us all in trouble and put us all in jail. And so to kind of set up the stage for this, we believe privacy is normal. It doesn't mean you're doing something bad. It just means that you want to keep your own business private. And that isn't some kind of new thing that we're not used to. And Callum will actually talk about how privacy used to be the thing when we dealt with cash, for example. Those are private transactions. And so just keep this in mind. This isn't totally mind-blowing stuff, but it hasn't been possible really in crypto at scale, which is actually mind-blowing that all of our transactions have been public so far and will continue to be forever, for as long as these blockchains run. Callum?
Cool, yeah. So we obviously started with cash. We've had cash for quite some time. It's been pretty good for us as a world population. And then cash was private, instant finality, so lots of good things about cash. And then we had Bitcoin and Ethereum, and it's great, yeah, we can now do it in a decentralized way. We can do instant-ish transactions. We can do it without getting permission from anyone. So it brought a lot of great features to us. But obviously, as you can see, we gave something up in the process. What we gave up was privacy. And actually, there was no way around it, right? When the first Bitcoin and when Ethereum were created, there was no other option than to make it public. But not in 2016, but in 2016 there was a seminal paper, Gross 16, which introduced a almost practical version of ZK, which was kind of the first one where we could actually use it at scale and make ZK work for us. Now, what is ZK? ZK is provable computation. And you can also hide some of the inputs, which is kind of an extra side benefit you get. What do we mean by provable computation? It means I can prove to you that I ran some code myself without showing you what that code, what the calculations of that code is, and without hiding some of the inputs and hiding some of the outputs, I can prove to you that I did it correctly. And so these properties sound great because they are great for privacy. And if we can introduce these into the blockchain concept, we can actually get some privacy. And that's exactly what happened with Zcash. So we got Zcash that was mostly based on this Gross 16 paper that enabled, for the first time, private transactions to happen on a kind of blockchain, or on a blockchain. Now, it was a little bit slow. It uses proof of work, so it uses some of the traditional things. It was based originally on Gross 16, which obviously we've had a lot of advancements in ZK technology since that paper. It's kind of been going on a massive trajectory of change. But they really did a great job there. But then we kind of forgot about it. And we were like, oh, no, actually, we don't care about privacy. We're scalability is everything that's important. Had DeFi summer, we need more transactions, more transactions, more transactions. Desperate for more transactions. So we had Optimism, we had Arbitrum, we had Solana. And they did a great job at increasing the throughput. And that's what we needed at the time. We kind of forgot about ZK. But then we had ZK Sync. Great. Some ZKs coming back into the world. We had Polygon Zero creating their ZK version. But I accidentally put it in the wrong place, because actually they're not using it for privacy. ZK Sync and Polygon Zero are actually using it for scalability. There's no privacy at all on those platforms. So what we actually had was Tornado Cash. Yeah, we know what happened there. I'm not going to go into detail. I don't want to go to jail. But the US government had some involvement, should we say. So that died. And so kind of what's next for privacy? Like how can privacy move forward in this context, in this environment? It's actually a relatively few people working on privacy. I haven't listed them all here. Obviously, we're working on privacy. Alio's one of the big ones, and Aztec, all three of those working on privacy. But I think the bigger question for us is kind of what next?
Right, and I think so far we've been living in this world where privacy and compliance and regulation are kind of at war with each other. We see this kind of every day in the crypto news, but we also see this playing out in technology, because up until now there was no really good way to reconcile the trade-off of privacy with compliance. And hopefully by the end of the talk, we can actually convince you that privacy and compliance can work well together. And it's going to take time. Obviously, it's going to take time for regulators to catch up with what's happening in technology, what the new innovations are. But we believe that this is kind of the way forward, and it's going to need to happen if we want privacy on-chain.
Yeah, so before we jump in about what could be the possible solutions, I think it's good to take a step back and look at what compliance do we have today? Like, how does it work on Ethereum? You know, Ethereum isn't being shut down by the US government, so hopefully that's a good sign. So Sandra is here, and she's got some money. She's been KYC'd by Coinbase, so all is good in the world. And she's got her money into crypto, and she's doing some transactions. She's doing a couple of nice little transactions. We don't actually know who these people are. Like, it's just an address, right? So there's some level of privacy there for her. I mean, those addresses could be doxed at any time, so semi-private. But from a compliance perspective, the government doesn't know who they are necessarily. What happens next is DPRK, just for fun, decides to send her $1, and that poisons her account. So now she's got a poisoned account. Coinbase are going to be like, not so much. And they're going to look at the OFAC SDN list, and they're going to be like, no, you're not doing that. Sandra very unhappy in this situation. So let's look at what that compliance involved. We were able to trace transactions history because everything was public. That's what Ethereum is good at, to show you didn't get involved with a bad address like Sandra did. And exchanges were able to check OFAC in order to allow someone to offboard if they didn't do that. Interestingly, we don't really care about the transaction amounts. Maybe we do, maybe we don't, but it wasn't the key thing that we're looking at there. And interestingly, again, we're not necessarily always interacting with KYC addresses. Like, you don't know who that address is, whether that address has been KYC'd. Doesn't seem to be too much of a problem. Again, we'll have to evaluate that. So the problem with privacy, though, is you lose the main thing, which is trace transaction history. Like, if you can't trace transaction history, how do I know you didn't do something bad? And then, obviously, because of that, you lose the exchanges being able to offboard. So can we solve this first one, and then maybe we get somewhere? Now, obviously, the solution is ZK, as it always is with privacy. So let's take a look at the same situation again. Sandra, she's got some more money. She's going to put it through Coinbase. And she's going to do some couple of transactions. Now, in this case, the address is definitely hidden. The amounts are definitely hidden. But what Sandra can do is she can actually create a ZK proof. And she can say, hey, I looked at the OFAC list. Here's my transaction history. This is all being computed by Sandra, by the way. And she's compiling this all together in a ZK and saying, hey, I did nothing wrong. And Coinbase only needs to see that proof that I did nothing wrong. And Coinbase is like, OK, fair enough. Like, here's your money. All is good in the world. So a little bit of technical design about how you could implement a solution like this. And this is our architecture at Polybase for our L2. So all of the data, and this is what keeps it private, is on the client. You can see either locally encrypted or encrypted in an external data store. And when you want to make a change to the state, like send a payment to someone, what I do is I transact the next state that should exist. I create a ZK proof to do that state. I take the old hash that lives in this rollup. So this rollup is a big Merkle tree of hashes. And I say, OK, here's the existing hash. Here's the proof. And here's the new hash. And that's all the rollup sees. when I send the transaction. You don't see any of the details of the transaction, just a hash and a proof. And with just those two things, the validator goes, oh yeah, I see that. That looks all good. And because each block has its own proof and root hash, because it's a Merkle tree, Sandra can use this. And of course, like, we handle that for her. She doesn't have to code it herself. But she's able to create a proof to say, hey, I didn't interact with any bad addresses, and therefore I'm a good person, and I want my money back. So the moral of the story is privacy and regulation don't need to be against each other. With ZK, we can really prove anything that we can get on Ethereum. Any kind of level of compliance we have on Ethereum, we can really bring back with ZK.
Cool. So one of the things we're announcing today is that the first product we're going to be shipping at Polybase is going to utilize some of the technology and processes that we just talked about to enable private USDC transactions. So quick breakdown, USDC is a stablecoin, as many of you probably know, issued by Circle, used widely. I believe it has a couple trillion in volume every month. About 1% of the US Fedwire monthly volume happens on USDC, transactions on chain, which is pretty amazing if you think about it. It's used for B2B payments, it's used for person-to-person payments. It's used around the world because access to stable currency is something that we take for granted in a lot of countries and doesn't exist in a lot of other countries, whether it be like business to person in terms of payroll or like for trade settlement or other use cases like that. So USDC is important, highly used, one of the very strong product market fits in crypto. But every single USDC transaction that's ever happened has been public. There's been a couple attempts at privacy, of course. We know Tornado Cash, but none of them have actually been something that regular people can use over a large period of time, scalable and compliant. And so we're going to be launching this. Our testnet is launching in November. Super, super excited for that. We're going to allow bridging of USDC onto Polybase. Eventually, that will be native USDC, so that's going to be even more secure. Working with Circle on that. And that mainnet is launching Q1 next year. So excited to kind of share that news with you guys today. And we have one more thing. This is an engineering-related release that we're doing today. We have launched Polylang, which is the easiest way to write zero-knowledge today. It's a TypeScript language. It's a compiler that the Polybase team built that compiles TypeScript, which is one of the most widely used languages in the world. I believe it is the most widely used language if you include JavaScript, which it derives from. And you're able to write ZK applications with that, just like you would write regular JavaScript applications. And that's available starting today. So if you go to polylang.dev, you can check that out. We have a little demo and documentation you can start building today.
Cool, yeah, I haven't much time, but I'm going to quickly go through. So as you can see, it looks pretty much similar to a Solidity contract or a TypeScript class. We just changed the keyword to contract. You've got your state at the top, constructor to create a new record, and a transfer function which does this. And this is all compiled to ZK. You do need a rollup in order to take one state to another, but this will do the proof for you. I will do. Oh yeah. Live demo. OK. So here is our playground. You can see I've got some code, a little Fibonacci sequence here. We put in the parameters, so what it's going to do. And up here, I'm just going to prove this. You can see we've got the proof is generated down here. It's like 48 kilobytes. And then I can just verify that. And in 32 milliseconds, I verified a proof in my browser. So yeah, that's Polylang. And then finally, one more thing.
There we go. There we go. 32 milliseconds. Love it.
We're hiring ZK devs. So if you're interested, come and work for us. Then yeah, have a look. Check it out.
Thank you, everyone.